Now, let us consider the most probable case, that is case 3, which is the average case analysis. Now, we have seen in earlier two cases that these two are the very trivial cases, that is, in one case there is no element in one part and all the n minus 1 elements are in the other part, and in other case, the best case, the array is divided into two equal parts every time. But these two are very trivial cases, which is more likely all sizes of the subarray are possible, because it is possible that when you are considering this array, the pivot can be in these positions. So, in that case there is no element in the left, that is I is equal to 0 and this is n minus 1. Then the next possible is I is equal to 1 and this is n minus 2. The third case is this is 2, this is n minus 3. So, that means all possible subarrays are equally likely. Okay. So, then what is the probability for any particular size where all sizes are equally likely? Because there are total n possible sizes starting from 0 to n minus 1, because the positions of the pivot can be beginning or end. So, if this positions is here, then the value of I is 0. If the positions of p is here, then the value of I is n minus 1. So, that means there are total possible subarray sizes are 0 to n minus 1, that is total n possible subarrays, and the probability for each is 1 by n. So, the probability that each of these sizes are equally likely will be 1 by n each. So, what is the average value? So, average value of T I as well as T n minus I minus 1, okay, this average value will be sum over T I, where I is the value of the size, and what are the possible values of I? Possible values of I is from 0 to n minus 1. The values of I is for 0 to n minus 1. So, if you sum all these things, this is the all possible sizes. So, average value is this divided by n. So, this is the average value for T I as well as T n minus I minus 1. So, both has the same value, average value. So, if you substitute this value here as well as here, so the expressions for T n, this will be this plus this. So, this will be 2 by n this plus C n. So, my reconciliations will be represented by T n is equal to 2 by n this value, that is the most average cases. So, analysis which ensures that all possible subarrays are equally likely, only for that this is valid. Now, how will we solve this? We cannot directly telescope this. So, we have to slightly rearrange it, so that we can apply telescopic expansion procedure. Now, if we multiply this both these sides by n, so we will have n T n is equal to 2 some I is equal to 0 to n minus 1 T I plus C n square. Let this is equations 1, and putting n is equal to n minus 1, we will have n minus 1 T n minus 1. Okay. So, this will be 2 I is equal to 0 to n is equal to n minus 2, this is n minus 2 up to n minus 2 T I plus C n minus 1 square, let this is 2. Now, if you subtract 2 from 1, that is after making 1 minus 2, we can have n T n minus n minus 1 T n minus 1, this value. that is equal to, from these two we can have only n minus 1, when I is equal to n minus 1, that terms left. So, 2 t n minus 1, because the remaining terms cancel out, plus c n square minus c n minus 1 square, that is c n square minus n minus 1 square. So, this is nothing but, this value is nothing but, if we can rearrange this, if we can bring this to this side. So, we can write n t n is equal to, this is n minus 1 plus 2, that is n plus 1 t n minus 1, this one, plus 2 c n minus c. Now, discarding the insignificant term, discarding this insignificant term and dividing both sides by n into n plus 1, we can have T n divided by n plus 1 is equal to T n minus 1 by n plus, this is 2 c by n plus 1, because we are dividing both sides by n into n plus 1. So, this is T n by n plus 1, this is T n minus 1 by n plus 2 c by n plus 1. Now, we can apply telescopic expansion. So, the next step will be T n, we are substituting n by n minus 1. So, T n by n, this will be T n minus 2 by n minus 1 plus 2 c by n. Next, this will continue. So, this will cancel out, similarly this will cancel out. So, when this will stop, this will stop when this value is 1, that is n minus 2 is 1, that is n is equal to 3. So, that is T 3 by T 3 by, so when this is equal to 3, that is T 2, this is T 2 by T 3, 3 is equal to T 1 by n minus 1 is, n is equal to 3, that is n minus 1 is 2, okay, plus 2 c by 3. Now, if you add all these things, so all these things will cancel out, left hand side it will be T n by n plus 1, and right hand side everything will cancel out, only these terms left out, that is T 1 by 2 plus sum of all these things, that is we can take 2 c common and sum over 1 by I, okay, where I is from 3 to n plus 1, because the term which is left out, that is 1 by 3, 2 c by 3, that is 1 by 3 and so on, last term is 1 by n plus 1. Now, this series is log n series. So, this series can be represented by log n plus 1 base e plus, so this term can be represented by log n plus 1 base e plus gamma, gamma is a constant, Euler constant, minus 3 by 2. Now, where gamma is known as Euler's constant, whose value is 0.577. So, we got this is a constant term. So, we have this right hand side is order of log n term. So, we can have from this T n by n plus 1, that is order of log n base e terms. So, T n is order of n log n base e. So, this is the average case analysis, where the running time is n log n, but here the base is e. Now, when this average case will occur, it is more justified analysis, because here we are not assuming that any particular size will occur always. All possible sizes are equally likely. Now, when we can ensure that this average case will be the result in all situations. If we have any inputted array and if we select the pivot element randomly between the starting positions low and high. So, the pivot will be any positions, because it is generated by randomly. So, in that case it is sure that all possible sub arrays are equally likely. There is no biasness, because we are selecting the pivot position, initial pivot positions, which is any particular positions starting from the beginning, that is low positions till any positions between high. So, in that case we can ensure that this average case will occur. Thank you very much, and in the next class we will see the heap sort.